The very foundational idea of how cells function is rather different from what we learn in the textbooks. And what we found is that water plays a central role in all of the biology that happens. It provides energy. I have a friend from Australia who was suffering cancer, and he decided to go where the sun is bright. He went to Mexico, and every morning and every evening he'd expose himself to the sun. And in a year and a half he was cured.
Professeur Gerald Pollack.
Well, hello to you, and happy to be here.
Yeah, I'm so delighted to be with you today and to have this chance to share about this fourth phase of water, which is a revolution in science and in the way we see biology. So it's an honor for me to have you here. So
well, thank you. Thank you.
Thank you very much. So you discovered that water has 4 phases and not 3 like we all learn at school, not solid, liquid, vapor, but also a 4th phase that you name it easy water. Could you tell us more about this?
Sure. Where shall I start? Well, it actually starts with a whole lot of anomalies. What are anomalies? Anomalies are observations that don't fit. So there's a gentleman, a scientist from England, Martin Chaplin, who lists the anomalies that exist under the paradigm of 3 phases of water. And the number keeps growing. I think it's in the 60s now. When you reach a point where the number of observations that don't fit is totaling in the dozens, you really need to ask yourself, is the theory okay? Can we, and generally what we do is we sweep those anomalies under the carpet. We think, well, we know that 3 phases must be right, and therefore anything that doesn't fit, we just sweep it under, and we think that sometime in the future someone will figure out how they do fit, because we know that the theory must be right. When it reaches the point that it's reached, then we have to raise the question, is something wrong with the central paradigm that we've all learned? Well, we found, and I must tell you that our work rests or stands on the shoulders of giants. This is not completely original. There was a famous scientist who was controversial named Gilbert Ling. And Ling came from China. He was chosen among the full population of China to be in the first cohort of people who came from China to study in the US. That was after World War II, 1948. There were 3 of them. There was a physicist who went on to win a Nobel Prize, a chemist who, my colleague tells me, also won a Nobel Prize, and then there was Gilbert Ling, who should have won at least 2 Nobel Prizes, but he was passed over. He was too controversial. And his argument was that in biology, in the cell is filled with a kind of structured water. And the idea is that the water is not like liquid water, because liquid water, we know, is the molecules of H2O are randomly disposed, and they're bouncing around a fierce number of times per second. And this water was different. Ling said, and he had a lot of evidence to support his point of view, he said that the water molecules were ordered, or he used the term structured. And so the idea is that inside the cell, if you would think of each water molecule as a dipole, a little bean with plus at one end, minus at the other, it's easy to envision how those molecules might stack on one another, like soldiers at attention, right? And that was his main point. He was awfully controversial, and he was dismissed as a crackpot by numerous people. On the other hand, his evidence was pretty compelling. So we built on his evidence. We found that mainly he was on target, but there were several observations that we made that didn't fit with his observation. So I'll just tell you about what we found and how it exactly differed, because the difference is really consequential, very consequential. So we found first that next, if you have water and you immerse some substance in the water, it had to be a hydrophilic substance, that is water-loving. What I mean by that is if you drop the water on the surface of this material, it spreads out, hydrophilic, as opposed to like water on Teflon, which beads up. So if it's hydrophilic, we found that next to this hydrophilic surface, there was a zone that built, and this zone would exclude everything, everything we looked at. And that's when we began to call it exclusion zone, right?
Easy
because
water.
it excludes. Easy, and easy is, easy to remember, but depending on what country you're from.
Yeah.
Sometimes it's EZ, so it doesn't work as well, but we call it easy. And later, we found that the properties of this water were vastly different from the properties of liquid water. And therefore, we began calling it fourth phase water. Because every property of this water, though the water was structured, as Gilbert Ling suggested, its properties were different from ordinary water. And one critical difference between what we found and what Gilbert Ling was opining is that the water was charged. Now, ordinary liquid water is not charged.
Yes.
It's neutral. So this water was charged. And if you think about it, this whole process begins with liquid water. You take a chamber filled with liquid water and you plunk down a gel or another hydrophilic material, and this negatively charged zone builds. But if the original was neutral and you got a negative zone, then there must be a positive zone somewhere else. And we found that too. So we found the easy water was negatively charged, and the region just beyond that was positively charged. And, that constitutes a battery. So it means that it's possible that water in some state, the fourth phase state, contains energy. Batteries contain energy. And in fact, we stuck electrodes, one in the negative, one in the positive, and we could get enough current to light an LED, light-emitting diode. So it really is a battery. Now, just one more point. Most, if not all, batteries need to be charged or recharged. You take your cell phone, right, and you forget to plug it in at night. Next morning, nothing, right?
No cell phone.
You've had that experience. So it's got to get the energy from somewhere to charge the battery. And I tell you, we were thinking about where would this energy come from? And I was scratching my head so much, and that's why I've lost all my hair, And finally, it was a young undergraduate student in the laboratory who got the answer, and I couldn't believe it. He was working on a laboratory bench, doing what I was just describing, a chamber with water, and put in a gel, and looking at the zone that excluded all the solutes that we put in. And I guess he was bored, and he noticed, well, my students are never bored. He noticed sitting right next to him was a lamp, a gooseneck lamp, one that you can kind of bend, and he shined it on the chamber. And he saw that the exclusion zone in the region that was illuminated, it just grew like crazy. He called me in to see what was going on. I couldn't believe what I was seeing, because there he had the answer, and the answer was light. So and naturally, we wanted to do serious experiments after this finding, and we checked a full array of different wavelengths of light, ranging at the short wavelength end of the spectrum of ultraviolet light through the visible spectrum and into the infrared. UV ultraviolet light did nothing. Visible light mostly did nothing, except when we got to the longer wavelengths, the reds, we began to see an effect. And as we moved into testing the infrared, the longest wavelengths, we found an amazing effect that you could actually, by shining really weak light in the infrared range, we could increase the size of the exclusion zone by something like 10 times. Very weak light did it. So the bottom line is that the EZ and the region beyond form a battery, which can supply energy, and we think it does supply energy. And this energy is recharged from infrared light, which is all around us all the time. We could turn off all the lights in this room, and your cell phone would record nothing, and your high acuity eyes would see nothing. But if I came with my infrared camera, that is an ordinary camera with a sensor that's sensitive to infrared instead of visible light, I get a beautiful image of everything in this room. And so that means that infrared light, infrared energy is all around us. And that's why military people tend to use it at nighttime, because you can see the tanks and the rifles and whatever that are around you, whereas your eyes can pick up nothing. So because infrared light is all around us all the time, it means that if we have the right situation, water next to a hydrophilic surface, fourth phase water will grow, because the energy that's required is all around us. Of course, we can add more energy, and then it grows bigger and better. But that's the essence of...
the biggest source of infrared is the sun?
The sun, absolutely. The sun is about 50% of the sun is infrared. That's why it feels warm.
And and I don't know if you know about the research of Dieter Breuer's solar revolution.
Tell me the name again.
Dieter Breuer's. It's a German physicist, quantum physicist, who made a lot of research in showing how the solar activity has an impact on us, on our body, on our consciousness. And I think, and we will see, we just have like a bit of an answer, because we are made of 99% of water in molecule. So if this easy water is growing and has more energy with infrared, and we are made of water, it means that the most we are in contact with the solar light, the easy water inside of our body is growing. Is it
absolutely,
right?
Absolutely. And I have a friend from Australia who was suffering cancer, and he decided to go where the sun is bright. He went to Mexico, Yucatan, and every morning and every evening he'd expose himself to the sun. And in a year and a half, he was cured.
No.
Yeah, it was cured.
Wow.
So, I mean, our cells are filled with easy water. That's perhaps one thing that I didn't emphasize at the beginning. And that easy water is necessary for function. And if our cells are deficient in easy water, our cells are not functioning properly. Mm-hmm. And what we need to do to restore function is to build the EZ. So it may well be that this friend who was suffering from cancer was basically rebuilding his EZ water in his cells to restore health.
Wow.
It works.
Yeah, it works. And you have the research and this concrete example about your friends. And you talked about Gilbert Ling, and you wrote a book that made everyone to understand in an easy way the research about of Gilbert Ling, the stem, cells, and engine of life.
Cells, gels, and the engines of life.
Exactly. And my next question is how your research is impacting everything that we know about biology today.
Good question. How many hours do we have?
1 minute.
1 minute, okay. While standing on one foot? Okay. Well, if you read a biology book, or cell biology or biochemistry, what you will learn is that water plays an insignificant role. Water is merely a bathing substance for the more important molecules of life. That is, nucleic acids, DNA, and proteins, and so it doesn't do anything. It's like, a bathtub full of water in which you bathe. If our results are on target, that concept is completely wrong. It's absolutely completely wrong, because what we found is that water plays a central role in all of the biology that happens. It provides energy, first of all, because while we think that all of the energy comes from the high energy phosphate bond in ATP, that's less secure than we think. There have been challenges in the past to that idea, and those challenges have not been addressed. So I'm not sure. It may be totally correct, totally right, but it might not be, and it needs to be addressed. What we found that water can contain energy, as I was just describing, and the question is the extent to which this energy is powering what we do. Sometimes you think of the breatharians who don't eat, and it's estimated by someone who's in the field teaching people how to do this, and she told me that there are approximately 300,000 such people in the world. I was shocked.
Wow.
You know, I thought it was a handful, but a lot of people simply don't eat for periods of time. I'm not talking about fasting for a day or two. I'm talking about long term. So the question is, well, you know, if they don't eat, where do they get their energy? And a possibility is that they get their energy from light, right? Infrared light especially, coming in.
Hinduist, here in Europe, we name it pranism, le pranism. And in the theory, they said it came from a Hinduist practice.
Yeah,
they say that
prana.
They get the energy and all they need from the prana, which is the light or...
Right, the light. And the light contains infrared energy at wavelengths just beyond what we can see. So yeah, you asked the impact of all this. And so the very foundational concept of how cells behave, if what we've found is correct, you know, you never know. Somebody can prove it wrong in the future, but from what we see today, the very foundational idea of how cells function is rather different from what we learn in the textbooks. And with each year, we learn more and more about how this functions, and we learn about, for example, the importance of having your cells really filled with easy water, and what you can do to refill your cells with easy water if they're not full. And there are a bunch of expedients that are not very difficult to realize or to achieve, and those keep people healthy. And you know, it's as simple as drinking more water, or drinking perhaps the right kind of water, or exposing yourself to infrared, going into a sauna, which is basically heat, which is roughly equivalent to infrared, and you feel good afterward. And the reason you feel good,
there exists today this infrared sauna. So you
have
the
yeah. You mean artificial lamps that you can? Yeah, they should do roughly the same, but sauna might be, or as the Finns say, sauna, and the Russians say banya. Maybe somewhat more effective. I'm not sure. But I remember myself having the experience of a Finnish sauna, and wow, did it transform me. I was at a conference, and I was suffering jet lag. It was Finland, and there was a party, and at 10 o'clock in the evening, the organizer gets up to the microphone and says, and I thought he was saying, okay, we can all return to the buses and we'll take you back to the hotel where you can go to sleep. He didn't say that. He said, okay, the saunas are now open. And that was not something that I was interested in hearing. But I was surprised. I was so tired. All I wanted to do was hit the sack. And I spent 20 minutes in one of the 3 saunas that they had. And wow, was I revived. I was ready to begin the next day after 20 minutes.
In this country like Finland, this Nordic country, could we see a statistic where people are healthier than other parts of the world?
I'm not sure. I can't comment. I know they tend to be happier. The Scandinavians are very high on the happiness scale.
Yeah, I know. I read.
And maybe that's because they enjoy good health, but I'm not sure of that. Sorry.
It's okay, Jerry. Now, I have a question. Could you give us like concrete health application that could be derived from your research?
I can give you two we've been working on. The first one is the most recent one, and that is dealing with cancer. And this takes several steps, if you don't mind. 50 years ago, there was a well-known scientist who was studying cells and cell division. And in cancer, the cells keep dividing to form a tumor. And he asked the question, what prompts cells, ordinary cells, to divide? And he found that it had to do with the electrical potential of the cell, that if the electrical potential, which in our healthy cells is minus 70 or 80 or 90 millivolts, if it goes down to near zero and stays there for some time, the cells will divide. And many studies have shown this in all different kinds of cancer cells, and also in cells that divide for a living. They all have a low electrical potential. Well, so it turns out that cancer cells that have been studied also have low electrical potential. A diverse series of cancer cells investigated by many different people, also 50 years ago roughly, found that instead of minus 80 or 90 or even 100 millivolts, typical cancer cells had electrical potentials on the order of 10, 15 millivolts. And so, it's sort of understandable that if that's what it takes for cells to divide, the cancer cells would just keep dividing. Mm-hmm. Yeah. So that's one hint. So what does it mean that, how do we understand about low electrical potential? Well, the cell is filled with easy water, and easy water is negatively charged. It doesn't take a rocket scientist to figure out that, the more negative charge you have in the cell, to give you this big negative electrical potential, the more easy water you have. So healthy cells are filled with easy water, and therefore they have a high negative electrical potential. But cancer cells have low electrical potential. They keep dividing. And why is that? And the answer, I believe, is that they're missing easy water. And if they're missing easy water, they can't function. So the cancer cells not only can't function like ordinary cells, but they just keep dividing. And therefore, it leads to serious consequences. And the upshot of all this is that one approach to reversing cancer is to do what you can to increase easy water in your cells. And I just mentioned a few of the expedients. There are more. And I've constructed a list of them, and they're not very complicated. And if you do those, as I was describing my friend in Australia, like exposing himself to infrared light, right,
to the sun,
yeah, and you can also,
light.
yeah, that should do it. Light, if you connect yourself to the earth is negatively charged. The negative charge seeps into your body, and we found experimentally that negative charge added to ordinary water converts that water to easy water. Mm-hmm. You see, so it's not very complicated.
Just going back to this connection to the earth, of course the ground is negatively charged, and I just had a beautiful experience weeks ago where friends of mine, we wanted to go trekking in the mountain, yeah, and he was like, I'm going without my shoes.
Oh, yeah.
Because he said, because the leather and even worse, the plastic is like cutting you from this negatively charged ground.
It's an insulator.
And I was like, that's a crazy idea, but I love to experiment. So I did this 1 hour walk in the forest without shoes. And I felt just amazing after that.
It should be.
So,
it should be.
Because it increased my easy water inside of
Sure, yeah. You can do it on the grass in your backyard. If you have grass in your backyard, take off your shoes and walk, especially if the grass is wet. It's a better conductor. Or I remember an experience. I grew up in New York City, and the summers are just impossibly hot. And so everybody would run to the beach. And I remember going to the beach with some friends of mine, and you know, we were fooling around. We were 10 years old, and so we decided to bury one another. And I remember getting buried up to here, and the tide was coming in, and it became apparent that, you know, to save my life, it was probably a good idea for me to get out. And I absolutely didn't want to get out from being buried. I didn't know at the time, but I remember the feeling so you know, as if it happened yesterday. It was pure bliss, pure pleasure being connected electrically with the earth. And I simply didn't want to get out from there, but of course I had to. I don't remember much from my youth, but I remember that feeling and that experience. So, so yeah, you can do it. Take off your shoes and walk in the forest, walk on the grass, walk on the edge of the beach near the water. You can hug a tree. All of those.
That's amazing to see how simple thing and also this grounding come from years and years of ancient wisdom. And today, like the brilliant scientist that you are just explaining to us that it's so important and to grow this easy water in our body that make us healthier and happier. And so there is, just to repeat, there is to increase this easy water, drink correct water, but today it's quite difficult to have like a really a water that hydrates you well. So that's the one point. Light, bright light, infrared, grounding. Is it other way to increase our easy water?
Yeah, there is a way, and it, like what you mentioned, it dates back to ancient India, to Ayurvedic period. They were awfully wise. We tend to discount their wisdom, but it's beginning to come back. We realize what. So one of the things that comes from Ayurvedic times is some of the herbs that they use, like turmeric, for example, and holy basil. And we wondered whether it's possible that these agents, which are known to be good for health, practically no matter what ails you, you take turmeric and you get better. And we wondered whether turmeric builds easy water. And we tested it. And not only turmeric, basil, but, and also various other expedients like, well, I can't remember all of them, but we tested a whole series of these agents. Ghee is another one that we looked at, you know, clarified butter, and they all build easy. And so, and we found aspirin does too. You know, aspirin is a natural substance coming from the bark of willow trees, and it was used by the ancients. And all of these that we studied built easy water. As a control, we studied glyphosate, the main ingredient in Roundup, which I don't know if it's used here in Europe, but it's widely used in the US. Yeah. And it kills weeds, and the question is whether it kills us as well. And we found that instead of building easy water, at every concentration we tested, it diminishes the amount of easy water. Wow. And so it may be, you know, this is a poison, and the question of poisons, is there a generality? We don't know the answer. Do most or many poisons work by wiping out easy water and therefore making our cells functionless? It's a question that remains. Do you have other example besides Roundup that attack this easy water? We don't, and one of the reasons we don't is that I'm reluctant to ask the students to work with poisons. Of course. Maybe when we get the right person in the laboratory. For example, an excess of sugar? Well, we didn't test that specifically. You know, sugar tends to build easy water because sugar forms sugar crystals. Maybe you did this as a child. You know, you put sugar in water and you let it dehydrate with a string, and it produces this rock candy, which is sugar basically with easy water around it, and children love it. Adults enjoy it too. So if anything, I would expect sugar to build easy water, not the opposite. And you know, when it comes to your blood, that's one area of your body where you want the viscosity to remain low because the blood's got to flow, right? And if you have sugar, if sugar builds easy water, then eating foods with high sugar will make your blood more viscous. So that's not good for your health necessarily.
For easy water, yes, but for the health, no.
That's right.
So we just saw a concrete health application from your studies. My next question will be maybe this easy battery to get. Like we all heard about the climatic change and so on, and environmental and energetical crisis, and it could be an easy application to use. It's like hydrophilic surface, water, liquid water, and then we help the easy water to grow, and then we have a battery.
Maybe you would like to come to my lab to develop it. Of course, absolutely, and of course we have this in our mind, and we have some evidence that it actually works. The real question is it going to be efficient? We think yes is the answer because the effect of light in separating charge is very much the same as the first step in photosynthesis. Plants use it all the time, right? Sun comes in, is absorbed, and step one out of, I think, 20 or so is the splitting of water into plus and minus. It's said to be 100% efficient. If it's 100% efficient, and we can realize it in some technological way, it could be really powerful. Yeah. And if you're saying, well, if it's so good, why don't you work on it? Why don't you develop it? And the main reason is we don't have funds to do it. You know, to hire somebody in the laboratory, we need grants or donations. And
so everyone that is seeing this episode that could be a conscious investor, here we go. We have something absolutely amazing. So.
Well, yeah.
Now we need more and more conscious investors.
I think this is worth a chance of developing, because if it works the way I think it is going to work, it could revolutionize the world.
Yeah, for sure.
So we have another one, a filtration device, and we call it a filterless filter, because there's no physical filter. And the way it works without diagram, it's a bit difficult, but you have the filter, consider it a box of some sort. And coming into the box is water that has contaminants in it. And what happens inside the box, in a very simple way, is that the water is converted into some easy water, and the rest of it is ordinary liquid water. And we can do that very easily. And if you collect the easy water, it's devoid of the contaminants that were coming in with the input water. So not only are you extracting water that has no contaminants, but it should be water that's good for your health.
Yeah. So do you think that you will go for commercialization of this filter? But because we all need this.
We don't, our laboratory is interested in fundamental science.
Yeah.
If somebody...
But are you discussing right now with an engineer that could use this filter?
We're discussing it, but
okay.
What we would like to do is let a company do the fabrication and such. But there are still, in both of these applications, there are scientific issues that need to be resolved. And we're happy, willing to carry out those studies, but we'd need funding for it. There are so many things that we're doing that we simply can't do everything because we don't have enough personnel to do it. And you have to make a choice. And so I mentioned to you getting electrical energy from water and light. It's really exciting. To do filtration based on the energy of the sun, because the sun in this black box, the sun's energy is what separates the water. You don't need a physical filter to do it. This water simply, by its very nature, excludes all the contaminants. We don't know all. We studied many. We can't say all because we haven't studied all. But there's a third thing, and that is desalination.
Yeah.
So this technique that we use, if you think of the salt as a contaminant of the pure water, it works the same way. And we have some preliminary evidence that salt can be separated in this way. This will require considerable effort to make it come to fruition, but this same apparatus could be used for desalination, and we think it has a lot of potential. Imagine what would happen if you took ocean water,
Yes.
Expose it to the sun, where places that need drinking water have lots of sunshine, usually, and there you go. Just put it in place and you get drinking water.
So many applications that will come from your research, I found. As I said, I'm really honored to have you on this interview and to hear about your research, and so happy to see all the different applications that are possible. And to conclude, how you see the future?
Oh my goodness, how do I see the future?
Well, what would be the future of your research besides the application? What's your vision?
I'm interested in my vision is to discover the real, true, foundational principles of nature.
Wow.
That's what I'm after, and I've got 3 books. 2 of them are about to come out. A third is I'm working on it, and I address fundamental issues like how do you understand the weather, for example? I mean, if I were to ask you, can you explain the development of a hurricane from first principles of physics and chemistry? And I think you wouldn't be able to do it. How does a thunderstorm happen? How do we sometimes get rain that's so pounding that people have measured the velocity of the rainfall, and they've concluded that it's not raindrops dropping to the earth, they're pulled to the earth in some way. Otherwise, it's not explainable. So these need explanation, and they need explanation from a fundamental point of view. And my next book is dealing with that among a half-dozen other issues that we think we understand, but we don't really understand them. And then the second book deals with the structure of the atom. And you think, I'm sure you think that the structure that we know about, like the solar system model with a nucleus and orbitals of electrons, must be correct because it's been in the textbooks for 5 or 6 generations. But there are some very fundamental issues that any middle school student could actually know to show that it doesn't work. Simplest of all, I know we don't have an infinite amount of time. The nucleus is positive, the electrons are negative. And I learned in middle school that minus attracts plus. So how come all those electrons don't collapse on the nucleus?
Yes.
Or, the other possibility is there's something fundamentally wrong with that model. Because we can't have a model that's unstable. This is unstable. But there are many other issues that we don't have time to talk about. Simple issues about, like the nucleus containing a lot of positive charges. They repel each other. And so why doesn't the nucleus explode? Physicists have invented a kind of glue that holds it together, like a Band-Aid to cover a gaping wound. It's called the strong force. But there's no independent evidence for a strong force. They invented it to cover up the problem. So,
you know, as an engineer that went through the normal process, you know, and now doing what I do with revealing and meeting brilliant physicists, I learned that we don't know much.
We don't know much
about nature.
Oh,
and
absolutely.
I'm really honored and grateful to have like scientists like you that are able and have the courage to rethink their paradigm, because not every people are able to do this. And I love this quote from Brian Greene, who said, people are saying that I'm doing like esoteric stuff with quantum physics. But as a scientist, I have two choices. Either I said I don't understand and I put it aside.
Yeah.
Either I do my work of scientist and I try to understand. And it's what you are doing, and thank you so much, Gerald.
Well, thank you for those
interesting
questions. I
appreciate it.
Thank you for
being my guest today.
My pleasure.
Thank you,
Thank you.
Jerry.